Welcome. Some familiar faces, some on. My name is Mark Donnelly. I'm a global solution architect with SUSE who works exclusively with our value partner, Fujitsu. And Fujitsu are driving a lot of business for us around our enterprise container management and associated technologies. So with that, we're doing this presentation in conjunction with.
Hi, I'm Dan. I'm a principal consultant at Fujitsu, and I'm here to help Mark talk about the work that we're doing together.
Mm-hmm. We have a set of slides. There's a lot of words on them. We'll probably go through them pretty quickly because some of it's pretty self-evident. We also have a demo, or more precisely, we have two demos. We have two separate harvester clusters where we're going to demonstrate some different things. And unlike some of the other demos I've seen this week, ours is live. So we're flying, you know, it's not recorded. So we're going to take our chances as we go. So this is our agenda for the next. How long do I have?
I think it's 45 minutes or 50 minutes.
Okay.
Along those lines in total. I think
okay. We're going to do a quick overview of Harvester, what Harvester is and what it can do. We'll talk about how that solution can help organizations solve real problems. You know, technology is cool, but with certain notable exceptions, we don't do it for its own sake. Right? We do it because we want to solve actual real-world problems. We are going to do the demos. Like I said, we're going to demonstrate some interesting things in Harvester, two separate harvesters, for a reason I'll explain when we get there. And then we're going to talk a little bit about solutions that are available from Fujitsu where you can get Harvester really easily. And then we'll do a little bit of Q&A at the end. Okay. Who's running Harvester? Is anyone running Harvester? Anyone here? Nope? Okay, good. That's the kind of answer I like because it means I can say anything. So, moving on. So, what is SUSE's Harvester HCI solution? Okay, HCI is hyperconverged infrastructure, which is a mouthful. And it's helpful to understand what HCI is, to think about CI without the H, converged infrastructure. And this was a big thing not that long ago. Hardware vendors like Fujitsu and Dell and HP and whatever, were selling converged infrastructure. And what that was essentially boxes of infrastructure sold as a single package. So you had some compute, some servers, you had some disk, you had some networking, and it was all sold in a nice convenient box. That was converged infrastructure, and you plugged it in, and you had like a little data center in a little box. Okay. The problem with that was the hardware was converged in this little box, but really it was all still separate components. Right? They just happened to package it up in a nice convenient little box. Which is what the next slide says. So, like I said, there's lots of words on the slides, but you probably noticed I'm going to ignore them. Feel free to take pictures if you want the wall of text. But the idea is, you know, this is awfully convenient, but still, really, you're talking about separate things. Separate switch, separate network, separate storage, separate compute. And the big thing that came along that allowed us to improve on that kind of architecture was the concept of virtualization. Okay? If you could virtualize on top of that converged hardware, then you get even greater convergence. Right? So now the network, you just make up the network on the fly because it's soft. Right? You have physical servers in the converged infrastructure, but you also have a virtualization layer that allows you to subdivide that. And that's where the term hyperconverged infrastructure came from. So essentially, the idea of hyperconverged infrastructure was to take this very useful technology of virtualization to run it on physically converged systems in a way that give us even greater level of convergence. So now your little data center's in the box, but you're not just limited to one network connection. You're not just limited to one compute node or two compute nodes or four nodes or however many blades you have. Now you can create any number of virtual machines you like. It's about utilizing the hardware. And this is a question that's really important for, I think, most organizations now. In case you haven't noticed, electricity is getting expensive. I know it is in my house. Someone offered me a server. Said, "Do you want this server a demo to work on at home?" I said, "Why would I want that in my house? I'd have to pay the electricity bill." Right? The greater convergence you can get, the greater density you can get onto the same hardware, right? The greater value there is, because you benefit from the administrative, but you also benefit from reduced cost all the way around. Less footprint, less energy consumption, less everything. Okay. So, what is Harvester? Harvester is SUSE's hyperconverged infrastructure solution. Okay. You install Harvester on metal, okay? Physical machines. You get physical machines and you install Harvester. What Harvester then does is it takes all of the hardware in the physical machines, the CPU, the memory, the networking, the storage, and it just bundles it all up nicely for you. And so now you have all the elements of a traditional data center virtualized. I suppose the elephant in the room, right? You've heard this exact thing before, probably from VMware, because that's what they do. It's the same story, right? And I'm guessing that a not insignificant number of you here just want me to answer the question: is can I replace VMware with Harvester? I'm guessing that's a question, right? And we are going to address that. We are, like Dan and I, we will address that. But for the moment, for the moment, let's park that, right? So this is what Harvester does. It gives you a single pane of glass for virtualization and cloud-native workloads. It is as is everything we do. It is 100% open source software. And so you can go and download Harvester and use it. You don't have to. You have to deal with us. But trust me, you want to. We're really nice people. And so the last point on this slide is Harvester leverages the agility, resilience, and portability of cloud-native technologies, which is a very long-winded way of saying Harvester is built, the underlying technology in Harvester is Kubernetes. Okay. So essentially, what we did was we said, look, there is this fantastic framework called Kubernetes, which allows us to manage containers. It allows us to create new containers, delete containers, schedule containers, migrate containers, do all this stuff across physical hardware. But why can't we just do the same thing with virtual machines? And the answer is you can, because there's a project called KubeVirt. And what KubeVirt does is essentially provides an interface between Kubernetes and the scheduling capabilities of Kubernetes and Linux KVM. KVM is the kernel virtual machine, not, what's the other meaning of KVM? Keyboard, video monitor, yeah. Yeah, so Linux kernel machine. So we take those two pieces. On the one hand, Kubernetes as a management layer. On the other hand, Linux KVM as a virtualization layer. And we exploit the fact that there's this lovely piece called KubeVirt that links those two worlds and allows Kubernetes to schedule virtual machines just like it does containers. And that's, in a nutshell, that's what Harvester is. There's a little more to it, because remember, we're talking about HCI, hyperconverged infrastructure. Right? So if it's hyperconverged infrastructure, we need storage. Right? So all the machines you might set up in a Harvester cluster will have disks, but how do we replicate data between the nodes so that if a machine goes down, that we don't lose access to the data? We'll talk about that. Harvester is, like I said, totally open source technology, no vendor lock-in, proprietary hardware, proprietary code, It's all, you run Harvester, fully open source, on generic industry standard x86 hardware. Pick your hardware vendor of choice. We obviously hope it's going to be Fujitsu. And the Kubernetes API is the standard for the entire stack, using this lovely thing called KubeVirt. What that means, though, beyond its usefulness now, looking to the future, because it's Kubernetes API, we have predictable integration with new technologies. Anything that comes out of the CNCF Cloud Native Foundation, such as CNI and CSI, this is CNI. What's CNI? Network, yes. And CSI? Storage, yeah. These are standardized ways for Kubernetes to interact with networking, virtualized networking, and virtualized storage. And therefore, because Harvester is just Kubernetes, it works for Harvester. This is what the architecture looks like. So at this level, we have nodes. Now, when it says nodes here, you need to be a little bit careful here, because you know how in the IT world, certain words have become overloaded. They have multiple meanings that might be very different or might be very close to each other, but not quite the same, and the meanings shade across things. In the Kubernetes world and the rancher world, because ranchers are nice control plane for Kubernetes, in the Kubernetes world, node has a certain meaning. That's not the meaning on this slide, right? What this means, that's a machine, it's a box, it's a physical piece of hardware. That's what we're referring to here. When we refer to Harvester nodes, this is a node. It's a physical machine. So on that physical machine, we need to run an operating system, right? You need an operating system. Now, the operating system is not explicitly called that in the diagram, but the operating system is bundled with Harvester. Harvester is like an appliance install. You take the Harvester ISO, you plug it in, you put it on a USB stick, you plug it into this server, and you install it. But of course, what are you getting? Operating system? Has to be an operating system, right? It's less, of course, because we're SUSE. Right? But you don't necessarily need to know that to deploy it, because the installation walks you through. But underneath, it's effectively installing SLES, SLE Micro. Technically, it's installing SLE Micro, a version, and technically there's a slight elaboration of that. But the important point is that it's the same SLES that's everywhere else. Okay. Harvester brings with it two important components. One of them I've already touched on is KubeVirt. KubeVirt is the piece that allows Kubernetes to manage Linux KVM virtual machines. The other piece we bring is something called Longhorn. Now, does anyone know what Longhorn is? Yeah. So Longhorn is our containerized storage solution. When you deploy Harvester, you effectively also deploy Longhorn. Now, as I discovered recently, there's a very interesting quirk here that you need to be aware of. What Longhorn does is Longhorn allows the storage that the physical nodes have to be pooled. So basically, each node has some disks. Longhorn takes those disks and bundles them all together. So it provides a single storage. And you can create storage using Longhorn, where you can define things like replication. How many times do you want a particular piece of data to be distributed across the nodes? If you've got 3 nodes, I think it's very interesting. I have a long history of working with clusters, high availability and stuff. And for diagram purposes, they always show, every diagram, and it's interesting, even in this whole new world, they show 2 nodes. But of course, 2 nodes is the worst case. It's the most complex case. Okay? What's the simplest cluster of more than 1 node? It's 3 nodes. Right? 2 nodes is a very unusual corner case. It's unusual in that it behaves differently typically than behaves differently typically than a 3-node or bigger cluster. But in this little example, in the diagram, you could tell Longhorn to create a virtual disk, a hyperconverged disk, by carving out of the existing storage it knows about, and say, I want you, if one of my virtual machines saves data to that disk, if that disk is presented to a virtual machine, I want you to write it to both nodes, to both physical nodes. So if one physical node dies, you still have your data. And people are wondering, but like, what happens if? And that's why don't think about what happens if, because 2 nodes is bad, right? It's not bad, but 2 nodes is the most complex case. Typically, we're going to have 3 nodes or more, and typically we're going to replicate the data 3 times. So if you lose 1 copy, you still have 2. Right? So that's what Longhorn does. And on top of that, then we install virtual machines. And we will show this in the demo. I'll do this live in the demo, hopefully. Hopefully. And by the way, you can tell me to shut up at any time, right? Because as you can probably tell, I like talking about these things. I just like talking, but that's, if it's something. Yes. Okay, so Harvester is enterprise-ready, easy-to-use infrastructure platform, leverages local direct touch storage. It uses Kubernetes APIs. It's very easy to get started. It's a bootable appliance. You download an ISO, put it on a USB stick, plug it into a physical machine, you've got a Harvester node. You've got a Harvester cluster technically, but it's only a 1-node cluster, right? But that's usable. You can use that. Fine, you have no fault tolerance, you have no failover, but it's usable. You can easily create, edit, clone, delete VMs. It does SSH key injection. I'm going very quickly over this because I will actually demo them. We're actually going to demo this. Yep. It's Linux KVM. So it's Linux KVM. But no, the reason I say ISO is that the product is shipped as an ISO image that you use to install. But what you're effectively doing is installing SLE Micro and KVM. And it can do VM live migration and so forth. You can backup, snapshot, restore your VMs. Harvester is supposed to distribute block storage. You've got network management, and then integration with Rancher. No, it is supported. Yes, it absolutely is. I didn't. Did I say it's not supported?
No, it just
Sorry, go back. Yes, it's sort of implying that you can get away with not using external storage. But in fact, to go back another slide or two, CSI. CSI drivers that control external storage, like NetApp or whatever, are fully, because it's Kubernetes. Yeah, there's one very important caveat. Okay. The VMs, their root disk, their boot device, can't be on the external storage. It has to be local. Either in Longhorn, distributed, or just local. But that's, thank you for bringing that. I forgot to mention, that's an important limitation you need to be aware of. You can attach any amount of external storage as long as there's a supported CSI driver for that storage type. But you cannot boot from it at the moment. So, okay. So integration with Rancher. It's Harvester is Kubernetes, Rancher is a Kubernetes management layer. So you manage Rancher you manage Harvester through Rancher because it's just Kubernetes. Okay, now this is the Harvester roadmap. I stole this, of course, from someone else. Hopefully they haven't changed it since I stole it, but you can go to the Harvester demo in the demo center and they'll happily tell you things. Where are we? We're here. We're Harvester 1.3. That's what you can download right now. Going forward, we're going to add some features. In October of this year, and then beyond we have a roadmap of other things we're going to add. I'm not going to go through every single feature. I will point out a couple of them though that are really, that version 1.3, which we released in March this year, was a very big release for us because they introduced a couple of really valuable features. The first one, VGU support. What do we mean by that? We mean being able to virtualize access to GPUs. Why is this important? AI. That's what everyone wants to do. They want to do AI, and if you want to do it in a virtualized fashion, that's what you need. Fujitsu's AI test drive, which is, have you seen, has anyone seen the Fujitsu AI test drive? It's a large-scale environment. There's actually two of them. There's one in London and there's one in Frankfurt, and that's for obviously political reasons, like data sovereignty, EU, non-EU reasons. And it's an environment. It is what its name suggests. It is a test drive. It's not a demo. If you go to Fujitsu, it's beyond the fact that it's a demo of the Fujitsu hardware. It's not demo data. They want you to bring your own data and test drive. Nor is it a cloud service. You're not going to live there, right? Fujitsu are in the business of selling hardware. They want you to say, oh, this is really cool, and buy some hardware and do it on-prem. But the Fujitsu AI test drive uses Harvester as a virtualization layer. So underneath, it's actually virtualizing things. And of course, because it's an AI test drive, we need this feature. We need vGPU support. The other thing I want to call out here is this, 2 nodes with witness support. Until version 1.3, Harvester did not support 2-node setups. You could run a single node, or you could run a 3-node cluster, or 3 or more, but it did not support 2-node clusters. Does anyone know why? Yeah, because Kubernetes, the etcd database, relies on a strict notion of quorum. Anyone who's been in the HA space will understand the concept of quorum. Basically, if you have a situation where the cluster splits, you need a way to resolve it in a definitive way, and it only works if you have more than 2 nodes, because if 2 nodes split, you get a 1-1 tie, right? And there's no way to resolve that. And this is an issue that every high availability solution confronts. And there's different ways you can try to resolve it. But it's not a technology limitation. This is a fact of life, right? Yeah. The way we have approached this in Harvester is we have introduced this concept of a witness. What the witness is, it's something else. It's a service running on a different machine, potentially in a different location, that acts as a tie-breaking vote. So it's not part of the Harvester cluster. Well, it kind of sort of is, but it's not a Harvester node. It's not a place you can schedule VMs. It's not part of the HCI, if you like. But what its purpose purely is to act as a tiebreaker. Now, you might think, well, if I'm going to do that, why would I not just get a 3rd node? And the answer is cost. Where are we going to run 2 nodes? Where do we see that as our use case? At the edge. Now, if you are, say, a retailer and you have 5,000 stores, and my business proposition to you is you put 3 nodes in every one of those stores. Or my business proposition to you is like you can put 2 nodes in every one of those stores and have a witness service running at central site. Commercially, that second offering is a much more attractive. Every 2 nodes need a dedicated witness in the sense of dedicated witness service, but you can multi-home the services. It's not another box service. Okay. So we see, yeah.
How fat is that witness service?
Very, very slim. Very, very slim. It's basically just a ping. It's not. I shouldn't have said that because now everyone thinks it's pinging it. It's not, but it's just a service running on a box somewhere that in the event of a tie provides a casting vote to one or other side. That's all it does. Now, we have this roadmap going forward. I'm not going to talk about it because I'm conscious of my time. Okay. We're going to talk now a little bit about how this can help people. So, Harvester primary use cases, we have a reference customer, ECKD, which is a German customer. This is a white paper available on our website where you can read about how they migrated to Harvester. We also, of course, have BMW. Now, this morning, you saw that, yeah? Keynote? Talking about Harvester. Do you want to say something to this, or do you want to take over?
No, I'll let you do this one because
well, I'm not going to. I'm conscious of time.
No,
so
fine.
It's a white paper. You can get it from our website that talks about the thing. This is what we're going to spend a little bit of time talking about. We're going to answer the VMware question now. Can Harvester replace VMware? And the answer is maybe. What we're saying is if you are in one of these boxes, Harvester may or may not be a good fit for you. Right? Essentially, anyone in the green column, anyone in the amber column, maybe, depends on their workload. You're probably going to need, if you're in this column, you're probably going to need a fairly significant evaluation. There's going to be a project just to look at the estate and decide what can move easily, what will move with difficulty, and what just can't be moved at all. Right. And then finally over here, we're looking at the people who really are not good customers for Harvester. Remember, Harvester is a Kubernetes solution. Harvester works best where you're scheduling your VMs and scheduling containers. Right. There's a lot of customers this age to move part of their application stack to microservices and containers. But there's certain legacy applications that they still need to run in VMs. Those are the customers for whom Harvester is the best fit. In fact, I will make a statement. I would say Harvester is a better fit than VMware because the container management is better. Right.
Yeah, absolutely. And so, thank you. There's a lot of information. One of the things that I'm most interested in talking to you about is exactly this. So, without breaching any NDAs, I'll try and tell you about some of the challenges that I've seen where this is a perfect fit. And what was being said before is absolutely right. So, we have, for example, I'm working right now with a very large retail customer who has tens of thousands of sites across the world. And they are in exactly the position that Mark was saying, where they will have legacy applications that for one reason or another they're either unwilling, unable, or have simply not planned for migrating away to any kind of containerized solution. Thank you. So for that kind of customer, Harvester is ideal because it allows us to provide them with a transitional period, let's call it, right? But it could be a longer period than just simply, a transition. And it allows us to proposition them, to provide them with that containerization development that help to get them into that place, to make use of new backend services that work with those containers, with stateless applications, for example, while also allowing them to continue running the applications. Now, one specific example that I've seen, especially for VM-based workloads, is things like screen controls. So they may have lots and lots of different screens, and the application was built for, a particular type of display of which they've purchased God knows how many thousands. Upgrading that is simply not feasible for them. So I think that from where I sit, there is a 100% match to the way that we would look at the kind of customers that we'd want to bring in, and the kind of customers where, if they had this desire to completely do a drop-in replacement, we would have to think about why it's not an appropriate solution. I'm not going to, I'll sort of try and go through these slides, and I'll try and put it into a format that makes sense, I guess, from a business perspective. So obviously bringing the traditional apps into the cloud native world, whenever I see cloud native, my particular mind, I come from software development, immediately goes to the public cloud, right? But obviously here we're talking about private cloud. And there are many situations where the private cloud is obviously key, right? I take an example from another side of the business I'm working with in Fujitsu, which is healthy living, so drug discovery, for example, where those businesses simply cannot place their data or their workloads in the public cloud. It's just not a feasible format for them. And taking that traditional IT solution and putting it into an HCI format is something that is much more palatable to them than us saying we're going to design this incredible thing that has to go into the public cloud, because the moment they hear public cloud, they just shut down. The idea of taking the bare metal and orchestrating it in a way that is not just faster, but is so much easier than doing it from scratch is, again, something that I personally, I can't overstate how important that is in trying to sell to customers and in trying to get people to start using schedulers and start using this kind of infrastructure. So, for example, the deployment of VMs, the management of VMs, the way that those are controlled, being able to use the same tooling across the board is obviously a massive, massive advantage. One of the things that I have personally seen, which is very problematic, is observability. And the way that that's normally done, the way that I've personally dealt with it before, is to always have some extra tooling. So, you put in some extra monitoring, you have something that looks at it this way, the way that this is being proposed from the harvester.
Can we go back to the diagram? Let me go back to here. That is a very good question. So if you take a look at this diagram, right? So we're showing on the diagram Longhorn and Harvester. And Longhorn has been it's kind of in the Harvester box, right? And when you get the Harvester ISO and you install Harvester, you are actually getting Longhorn. Okay. But that Longhorn is intended to take the disks in the physical node and make them available to the VMs. Right? And that is the bundled Longhorn with Harvester. And that's part of the Harvester product included. But if you then subsequently choose to run a Rancher cluster to manage containers on those VMs, right? And you want some of those containers to be able to consume the storage, the Longhorn storage provided by Harvester, that is a different subscription. And that is the critical point. So the Harvester subscription includes support for Longhorn to provide block devices to VMs. If you want to provide storage through Longhorn to containers running above that again, that is a different subscription. And it's confusing. To make it even more confusing, Rancher counts nodes. Remember I said the word node is overstated? Is overloaded? If you're running a containerized layer up here, those are Rancher nodes. And that's different from the sense that node is used here. And subscriptions are per node. It is, I apologize, terribly confusing. I mean, I get confused by it. Yeah. Counting nodes is hard because nodes has different meanings. Sorry. Well, so you purchase Rancher subscriptions based on the number of managed Rancher nodes. You may or may not require Longhorn for all of those. I mean, some services just don't need persistent storage, right? So you don't need. So it gets very confusing, and the best way to do this is to purchase Rancher Prime, because then it's all in the box and you. So, shall we switch to the demo? Yeah, let's do that. So, this is a very, very simple, very clean, by which I mean little used, harvester cluster. And as you can see, I've got 3 hosts. I've got 48 virtual machines. I've got 2 VM networks, 8 images, 59 volumes, and so on. This is an environment that our solution architects who support our sales organization use. There are many tenants on this. So what you're seeing here in the dashboard is the overall view of the cluster. So you see we've got so much memory, so much CPU, so much storage. And there are 3 hosts. And what does host mean in this case now? This is nodes, right? This is physical. There are 3 physical machines is the thing. But what I want to show you just very quickly is if I look at virtual... Yeah, so if you pay attention to this, there's 48 virtual machines. If I go here, there's only 1. Do you see that? On the dashboard, it said there were 48 virtual machines.
So 48 instances. The same.
No, there's only 1. If you look right up at the top, do you see right up there where it says S. McBride? It's a namespace. Right, yeah. There are multiple namespaces in the cluster because it's multi-tenanted. Each of the solution architects has a namespace in which they can work. My friend Steve McBride gave me access to his namespace. There was nothing in it. I installed this virtual machine just a little while ago. But if I go back to the dashboard, I see the if I go back to the dashboard, I see the total. There are multiple namespaces on the cluster because there are multiple users. And there are 48 virtual machines defined in total across the namespaces. Let me just show you very quickly, though, the process of doing this. So if I look here, I will show you this same page on the second cluster because I want you to pay attention to the thing here. I'm just going to very quickly do this. I'm going to go create. I'm going to say, okay, let's give it a name. Let's call it SUSEcon 2. It's virtual machine. I can give it a name. Let's give it 4 CPUs. Let's be greedy and 16 gigs. And we're going to use Steve's existing SSH key. We're going to insert the SSH key in. Yeah. So I'm going to do all this, and I'm going to just go to the volumes, and I'm going to select as on. These are the install issues. So I'm going to select as a volume. Let's do /15 SP5 minimal install, and I'm just going to hit create. And it's going to go do its thing. And it's thinking, you see, it says it's starting. VM is reported as not running. Let's take a look at the console. This sometimes is a little flaky on my browser because I'm paranoid, and my browser is really locked down. But it definitely worked earlier, so it should do its thing. Let's let that run. Let's let that do its thing. That's the first cluster. I just deployed a virtual machine, right? It worked. But I want to look at the other cluster. Okay, this is a different cluster. A completely different harvester cluster, different physical machines, different part of the world. Notice in this one, if I look at the dashboard, there's 4 hosts in this one. One of the hosts is marked as red. I'll explain what that means in a second. I'll come to that. But there's 4 hosts. There's 3 virtual machines. So if I click over to the virtual machines, these are the virtual machines, test 1, CKS worker. These are what they're called. I didn't create these. I don't even know what they are. I don't know what they're being used for, but I borrowed this cluster from a friend. And remember I created the virtual machine on the other cluster? How did I do that? Well, I went over here, and I clicked on the Create button. What Create button? You see that? There's no create button here. And the reason why is because of role-based access control. I am logged into this cluster as a user with less privileges than on the other cluster. And I cannot actually create a VM. I can see things, but I can't do things. And so on this cluster, it's kind of different, right? The experience is different because I'm logged in as I'm logged in as myself in both cases. But the basic difference is that on this cluster I don't have full rights, and on the other cluster I do. And hence I could create the virtual machine on the other cluster, but I can't create the virtual machine on this cluster. And this has still not. This sometimes works if I just hit the reboot. So the other thing I want to show you on this cluster that is so fascinating is this, the red. Do you remember one of the hosts was marked as red? You see here, and it's now red, and it's HC1C is remember, the host is node, is physical machine, and it is cordoned. It's cordoned because the node is broken. The machine is broken. The machine's actually physically broken. And when I borrowed this cluster from my friend Alex, he said to me, do you want me to clean that up? And I said, no, leave it. Because look what he has done. He had 3 physical nodes. He had 3 physical nodes, and one of them broke. So now he's got 2 nodes. Okay. And yes, in that case, any virtual machines that are running on the broken node would have failed over to a running node, and that's great. But now he's effective, because he's not replaced the machine, he's effectively got a 2-node cluster. And so now he can't take another failure. Right? So until he gets his machine replaced, he cannot. It's running, but he cannot survive another failure. So what has he done? He has added a witness node. That's what that is. That is the witness node that he's running. So he's actually sort of turned his 3-node cluster into a 2-node cluster with a witness node. And this was not arranged. He said, yeah, I have a cluster you can use, but it's kind of broken at the moment. Do you want? But I can clean it up for you. And I said, no, leave it. That's really cool. So he effectively just added the witness node to the broken 3-node cluster to make it a 3-node cluster again. Well, it's not a 3-node cluster. It's a 2-node cluster with a witness node, which is different. This machine cannot run virtual machines. No, not really. Not here.
So
Yeah, the double. Yeah, that's what Alex called it. But that's arbitrary. He could have called it anything. He could. Well, that's the. I'm very disappointed in this console did not appear. Let me just try that again. This by the way, this is not a reflection on the product. This is me. It's my browser. Sometimes it works. Sometimes it doesn't. Yay! Worked. For some reason, it seems to work. So that's the machine I just installed, SUSE 2. You notice it created the host name is set to SUSE 2 because it's using the cloud init. The image was our cloud image, so it's using the cloud init. So it names the machine. The name I gave it is, and it injects the SSH key that I mentioned. I can't log into it from an SSH client though because I don't have Steve McBride's private key. So, but it's injected his key into the image, and it's now running. And I can now do the best part of every demo. Restart it or cause it to fail. You see, it's running in the harvester cluster. I can just run. Okay. Do you want to re-engage?
So I'll be very, very quick. So in short, Fujitsu's plan and what we're working on at the moment is called Uscale. And the idea behind this is that we are creating a product that can be purchased by customers as a clearly defined, clearly costed solution where you can, we can provide to customers the entire stack of infrastructure as code, orchestration, observability, configuration management, and everything else that comes along with that, especially aimed for us at Edge Solutions. As I mentioned, we have a specific customer in mind initially for this. The scalability and the reutilization is obviously very important. It's, again, a very, very important, it's a very challenging part of going to the public cloud, because scalability and the costs associated with that can get very, very confusing and very, very expensive very quickly. And that is part of what UScale means. I encourage you to go downstairs and talk to the people who know much more about this than myself. But the idea behind it is that you will be able to purchase this product, you will know how much capacity you have, and that way you don't run into the issues that you would have in the public cloud. And by integrating and by using Harvester, we can also leverage all of the knowledge that we have in CI/CD, inside GitOps, and to be able to provide customers with something that they can actually deliver from a single control plane. Have we completely run out of time? Yeah, okay. Obviously, I've spoken about this. The suboptimal use is a consistent challenge. The fact that Harvester can provide vertical scaling within the same cluster is obviously a massive advantage, and it allows customers to take those workloads and scale them as they need to. The cloud native principles have been already alluded to. Have we? Okay, we've got to go. I apologize. So, sorry. So yeah, please feel free to go downstairs and talk to people who are perhaps a little bit more awake and a little bit more coherent than I am. But it's the AI test drive, as was mentioned, runs on this. There is a stack which is available both in London and in Europe.